Welcome dear students. In the last lecture we discussed in detail what is tautomerism and what is the type of the tautomerism which is called as the prototropism. Now this lecture is about the Valence Tautomerism. If you want to watch my lecture about the prototropism and what is tropism and what are the conditions and characteristics of the tautomerism, I will paste the link in the description of the video. You can watch that lecture. This one is the second type of the tautomerism, which is the Valence Tautomerism. Valence Tautomerism is basically due to continuous formation and breakage of single and double bonds in a compound without migration of an atom or group of atoms. So my dear students, tautomerism is of two types. One is the Valence tautomerism and the second one was prototropism or prototropy. In prototropy, there was shifting of the atom, particularly proton, which was H positive ion, and the prototropy exists due to the shifting of the H positive ion from one atom to the other atom within a compound. That type of tautomerism is called as prototropy. While in the second type, which is valence tautomerism, in this tautomerism there is no shifting of the atom or group of atoms or H positive ion from one atom to the other atom within a compound. Rather, this valence tautomerism is due to continuous formation and breakage of single and double bond in a compound, and there will be no migration. Here is without, mean there will be no migration of any atom or group of atoms in a compound. So you can say in valence tautomerism there is relocation of bonds, and in prototropism or prototropy there is relocation of the atoms or the group of atoms. And keep in mind that valence tautomerism is a more rapid transformation or interconversion of compounds. So valence tautomerism is a more rapid interconversion of the two compounds which are tautomers of each other, while prototropism or prototropy, that is also interconversion of the compounds, but that interconversion is not that rapid. In valence tautomerism, again the tautomers they exist at dynamic equilibrium. Now let us take two examples, one from prototropy and other from valence tautomerism. This one is amino acid. It converts to its tautomer, which is zwitterine. Now my dear students, in this particular case, this hydrogen atom is shifted from this carboxyl group to this amine group. So there is shifting of hydrogen from carboxyl group to the amine group, and this other form of the amino acid is created. Now these are two tautomers of each other, and this type of the shifting, that is the shifting of the atom from one part to the other part within the compound, that is called as the prototropy, or you can say it is called as the prototropism. So this one is an example of the prototropism. Now I will give example of the valence tautomerism so that we can differentiate between these two. This one, it is benzene oxide. It converts to this compound, which is oxygen. Now, my dear students, you can see that in this particular case in which benzene oxide is changed to oxygen, in this case there is no shifting of the atom, rather the bond shifting has taken place. Only the bond is shifted inside the ring and this compound is produced while all the atoms they are at their place. So this one is an example of the valence tautomerism. In this case, hydrogen is shifted from one part of the group to the other part within the same compound. But in this, there is no shifting of hydrogen or there is no shifting of any atom from one part to the other part. Rather, the bonding arrangement is changed and the relocation of the bonds has taken place. So this one is an example of the valence tautomerism, and this one is more rapid as conversion as compared to the prototropism. Mean benzene oxide and oxygen, they will be more rapidly interconverting as compared to the interconversion of the amino acid and the zwitterine. So prototropism is the movement of hydrogen from one part of the compound to the other part of the compound, and this relocation of the hydrogen atom has taken place within this compound from one part to the other part. But while in valence tautomerism, no hydrogen atom or group of atom move from one portion to the other portion, rather the bonds are relocated and the second tautomer that is arisen or that has arisen. So this is the difference between the prototropism and valence tautomerism. And at the dynamic equilibrium, which structure will be more in the dynamic mixer, that depends upon the external conditions like temperature, like the solvent in which all these interconversions are taking place. So which one will be dominant or which one will be more in dynamic mixer, that totally depends upon the external conditions. So I hope so the idea of the valence tautomerism that will be clear to you people. See you in the next video. Till then, take care.